I think it's incredibly important to spend most of our time in the real world because you can't really know about real world problems without being in the real world, which is only outside of the lab. One day outside of the lab is worth a year in the lab. People have been imagining building robots for a very long time. This goes back hundreds of years.
No longer the stuff of fantasy, robots are beginning to assume many duties once reserved for human beings.
People used to build robots that were sort of snake-like arms and maybe trash can-like robots. Little clunky things that rolled on the ground. But now we're in a completely different place. Now we're building almost anything that we can imagine. Things that swim, things that fly, things that go into human bodies, and things that hopefully soon go into our homes as well. Robots are machines in this world that we're all sharing physically. They're not in the cyber world. They're right here with us. We're trying to create machines that behave in really supportive ways and help people understand their own behavior. Unfortunately, sometimes when we see people with differences, with challenges, we can't always relate. It's hard to imagine what it's like to be frail and elderly, or what it's like for a child with autism who is not able to make eye contact. What if robots could be programmed to have more empathy for others?
Hi, my name is Blossom.
It incorporates the features that make a robot, a computer with muscles.
I have no concerns about the robot apocalypse, robots going rogue and doing bad things.
Who can control this monstrous creature?
Because they should not be programmed to do that. People are the ones that make the machines, and we have the choice to make these helpful assistive devices or not. The really important question is, who is it going to help? My name is Maya Matarik. I'm a researcher in AI and robotics, and I'm a professor of computer science, neuroscience, and pediatrics at the University of Southern California. What I love about engineering is you see something that needs to be done, and beyond just discovering the problem and what it's about, you actually try to do something about it.
What we're observing here is data-driven processing in action.
The work that I am doing is really at the intersection of robotics, computing, and psychology. Because what I'm interested in are things that are really hard for people to do psychologically, not just physically. It's hard physically to carry something heavy, so you can get a machine to do it. But things that are psychologically difficult, that take a lot of support, usually people don't get that support, which is sometimes needed 24/7. And one of the things that machines can do is have that empathy. I'm interested in creating physical machines, robots, that are like peers, like coaches for people when there aren't other people around to help. Humanity is beset by challenges with health, with physical ability, increasingly cognitive ability as well. As a society, we have a lot of inequities. You can imagine developing machines that help people who need help, as opposed to removing people. I really push for augmentation of human ability versus automation of work. People always wonder how a machine can have empathy and relate, because we tend to think of empathy as being something that you feel. But actually, if you look at psychology about empathy, empathy is more about what you do than what you feel. And so in that sense, a machine can express empathy. A machine can say things like, I see that you're in pain. I am so sorry. How can I help you? People may not believe that it feels pain, but is that important? Or what really matters is what it does. And so we're at a brink of a real revolution in terms of what machines could be doing for humanity. We're trying to create machines that behave in empathetic, engaged, helpful ways. You can create the simplest of machines, literally a thing that moves around randomly on the floor, and people will attribute lifelike characteristics to it. They might say things like, oh, it likes me. When we build robots, we build on that. in my lab, we're really focused on what behavior humans display that is valuable and helpful. And we try to create that in machines. My dad had been an engineer. He died of cancer when I was 16. And he always told me that it's incredibly important to have heart in science. If you don't have heart, you don't choose the really important questions. And I eventually became an engineer because what I love is solving problems. And I definitely get that from him. What I'm working on is ultimately about human health, using technology to help people change their behavior towards wellness. And when we created this field, we really looked at where there was the most need. And we very early on identified autism, which is a challenge now affecting 1 in every 45 children in the United States in terms of social, behavioral, and emotional challenges. Autism is probably the hardest test of inclusiveness and empathy because it's different for every child. So you get this spectrum of symptoms and severities. And often individuals may not know how to be socially engaging and friendly, and that makes people have less empathy for them. So it's a vicious cycle. We had an incredible opportunity to be part of a project funded by the National Science Foundation where we got to develop completely new robots to live in the homes of families that had children with autism. And the children would interact with the robot every day. We found if we create a therapeutic interaction, that children on the autism spectrum can start to be better at eye contact, at taking turns, at starting to play with others. It can make a tremendous difference to introduce this playful, personalized entity in the child's life.
Michael had social skill classes, but it is different when you're trying to use those skills in real life. The nervousness doesn't go away the first time you're meeting someone.
Hi, my name is Blossom. Welcome to my home, the USC Interaction Lab. Here, my robot friends and I want to try our best to help people in the world. Can I ask what's your name?
I'm Michael.
Nice to meet you, Michael. I am so happy that you came here to meet with me today, and I would like to be friends with you. Would you like to be friends with me too?
Yes.
That's awesome. I think we will become good friends. Sometimes I am really nervous when talking with someone for the first time. Do you ever feel this way?
Yes.
I am glad that we can relate. On the bright side, my friend Joanna recommended a really useful exercise to help us feel better whenever we have these feelings. Are you ready to try it out with me?
Yes.
Terrific. You are not afraid of challenging yourself, and that is awesome. First, let your body relax a bit. Breathe in. Out. In. Out. Awesome. For the next few moments, just relax and rest. It feels good to relax. Enjoy this calm feeling.
This robot guides Michael through a mindfulness breathing exercise to help Michael to feel calm when he has negative thoughts or feelings. For children with ASD, it's very easy for them to be distracted or disengaged. So one of the main things our lab have been working on is train the algorithm to perceive engagement level in real time and provide socially appropriate feedback to re-engage the child back to the exercise or the interaction.
And you can shake your body to let your body wake up. Thank you for taking the time to meet with me and join me in these exercises. Next time you have nervous or uncomfortable feelings, What we can do is to try these exercises to keep our attention on our breath. I am so happy we became friends today.
Well done, Michael. Do you feel a bit more relaxed?
I'm feeling less nervous and more relaxed.
Would you want maybe a Blossom at home in the future?
Yes, Blossom is always a good friend. And I want to play with her in the future.
You need to really work with the population. For example, working with the parents, talking what they really need and how we could potentially design the robots for this population.
I really wish he had something like this when he was younger. He is a bit shy, but he's more than that. And I think putting the social skills together with some type of little pal would be helpful. And I can see him with this by himself, engaging more, than with the teacher sitting there, or me even.
The human parts are so important, and I feel like the future of AI technology should be human-centered. It should be designed by the people, with the people, and for the people, so it can do good. That vision drives everyone in this lab to work on research like this.
Now, we have seen that people will actually be empathetic towards machines. We're interested in machines really feeling empathy for people and then getting into that loop back and forth. For example, doctors are trained to act in an empathetic way because they are preferred if they appear empathetic, whether they actually are or not. In fact, it is a fact that doctors that are less effective, if they're thought to be more empathetic, they're preferred by patients. So it's more important to seem empathetic than to be actually effective. That tells us something about what people value. So it's how do you build that thing? And with machines, you just program the machine to be automatically compassionate. So you get that hook to start with. And that's very powerful. But then we have to bridge this gap between what the machine can do and what the person needs by using machine learning. So there are all kinds of different machine learning approaches, but all it really is it's statistics with numbers that represent the data coming in. So like if I'm looking at someone's face, the video data get translated into numbers, and we look at those numbers over lots of different faces, and we see things that are common. And we'll use machine learning to analyze what represents compassion. Is it something in the face? Is it something in the tone of voice? Is it in the pose of the body? If we take a lot of data, lots of different people across cultures, ages, genders, expressing what we would call empathy, and then we extract what all these different people have in common. We're also interested in going into a nursing home, a therapy center, a school, and observing natural interactions, because those data, they're messy, they're noisy, but they're real. Hey, Lauren.
Hey, Maya.
So what are we doing today?
So today we'll be having Alma and Kian come in for the mom-baby interaction. We'll be recording them with this webcam, and then we'll be using open source software to track their poses throughout that video. And then the metrics that we've been developing will be used to monitor their pose coordination and how they're coordinating their vocalizations, so that we can kind of assess when the state of their interaction changes. For example, if Kian gets fussy or if they change activity, we can look at how those metrics are evolving with time.
So the goal is to really help parents monitor over time, right?
Exactly, yeah, and then give that data to the clinicians that they're working with so that they can have some feedback about how those interactions are going.
Should we do another song? What do you think? Yeah? Okay. He marched into the left, he marched into the left, he marched until they're upside down. Oh, what a silly sight. Woo!
These are coordination values, so higher values indicate like a higher level of responsiveness of mom in response to her infant.
Do you want more? Yeah or no? No? What do you want to do?
Why are you working with such young children?
Because it's hard. There's actually active research going on to understand the relationship between mother-infant interaction and atypical development or adverse childhood experiences. And because it's so unknown, we want to record this video footage and evaluate these coordination metrics so that we can support that type of research at scale.
It's so compelling because if we catch it early, it really can have a positive impact for their whole life. When you're a baby, you have lots of months and years to learn things, and that's all you're doing. But when you're an adult, it still takes months and years to relearn things. For example, if you've had a stroke, your brain has to relearn how to use your body. It's very difficult and depressing to keep dropping things until you learn to use your arm again. So you don't, and your brain never recovers. And it can be very demoralizing and lonely. Being lonely physiologically makes the body function less well. We are social creatures. We thrive when we're around other people, especially if we have positive relationships. And so many elderly people are just so alone. My mom is 87 and needs help. And we could have technologies to offer that support when it's needed. So one of the reasons that we're using robotics in the first place is because robots are machines in this world that we're all sharing physically. They're not in the cyber world. They're right here with us. So we have to stay really careful about that if we introduce things like virtual reality, augmented reality, because we don't want to lose that grounding in the shared world. We're just starting to open up this whole new area of robotics research, which brings together augmented reality and virtual realities into robotics in order to create kind of a shared world for the robot and the user. So for example, we might have an elderly person wear AR goggles to interact with the robot. So they're sharing this augmented world in which they can get to know each other better.
You can do augmented reality either through a headset or you can do it through something like a phone. And what's great about augmented reality is I can still see the world around me. It's still a shared space. The idea is to have companions even when some people are alone. Older adults are a huge spectrum of experience and differences on what they want. And a lot of it is about acceptance of technology for us. What we focused on is how can we make these robots more approachable for older adults. Gene, do you want it so you can keep your glasses on? It fits over your glasses.
Yeah, we may do that.
Have you ever done VR before or anything? Or
No.
This is first time, right?
Yeah.
Yeah. It's a little odd, little finicky. You have all these things in the actual space, so you have to move around to actually use them. And you can grab this controller and move it back a little too if you'd like.
You mean like?
Yeah. Could you just describe a little bit about what you see right now?
I see the robot floating in the air, and it's translucent, so I can see through it.
Look over here more on the right.
Okay, yes.
Yeah, so you see, what do you think that is?
That is the robot looking at me. Part of the fascination for me is learning how to operate the control. For older people, we're living longer, and we're experiencing more and doing more. Using the brain builds those cells that you're creating every day.
And what's great about augmented reality is I can still see the world around me, and you can even have multiple people with the same virtual augmented reality world in front of you.
Doing something, not just the same activity, but something new, increases longevity. And I think the more feedback that the robot gives, the more it's going to entice them to do things.
It's incredibly important to give people personalized help with whatever challenge they have. There's healing the body, but then there's healing the brain in order to heal the body. And we wanted to do the two together. If we're honest with ourselves, we realize that we all go through times in life when we need some help. Do we get that help? Do we get as much as we would like? Is it available 24/7? Unfortunately not. But I think the really bright future ahead of these personalized technologies is to have affordable, accessible systems that can help with specific needs. It's an exciting time in the field. And I've felt like that all along. But definitely things are accelerating because we have tools that are allowing us to leap. We have faster computing. We have data like we never did before. Everything is cheaper, smaller, faster, and hopefully more affordable. And so as long as people make sure that we're getting broad data and inclusion, the potential is really endless. We, right now, are shaping the future. I am really optimistic about how aware and attuned young people are to all of the issues in the world. Younger generations that are coming through are more aware, more worried, but hopefully more willing to tackle these hard problems. With all of these things that we do, these machines that we're building, young people who are right now in middle school, high school, college, they're the ones that are going to make all the difference. And there's tremendous opportunity and also tremendous responsibility. But there's really this sense that you can make a lot of difference, and everyone can. This field that we created, socially assisted robotics, it didn't exist 17 years ago. We created it because it needed to be. It needed to come about. Over the years, we worked with Alzheimer's patients, elderly people, stroke patients, children on the autism spectrum. In the end, they really are very similar. They're individuals who all need empathy, compassion, and someone to care. So, Baka, do you want to go for a walk?
Well, I would prefer not to, but if you want, we are going.
Yes, that's true. Yes, we're going.
Like every day. Oh!
All right, let's go for a walk. So you could say to care is to have empathy, is to feel what another person feels. But I would say caring is just doing something to make life better for someone else. It's not about feeling, it's about doing. That is something very concrete. When I do something to make you feel better, that is very measurable. That has impact. So we focus on action. And robots are great for action. They do things.
It's hot. I'm old.
You're not old.
Sweaty. I need a shower.
We'll after the one. You're not old.
Of course.